Okay. All right, so first thing we're going to talk about is just some vocabulary because polynomials have a lot of fancy terms that we use to name different polynomials. So I would like for you guys to be familiar with these so it does not confuse you if you hear them used. Okay? So a polynomial is an expression with more than one term. A term is a group of numbers and variables multiplied together. I don't know why I didn't capitalize that T right there. Terms are separated by plus or minus signs. So, for example, something like 3x squared plus 5x minus 7 would have 3 terms. It would be a polynomial. Your first term right here would be the 3x squared. The second one would be the 5x, and the last one would be the 7. So terms are going to be separated out by plus or minus signs. Polynomial is going to have more than one term. Okay? So there are 2 ways that we are going to name polynomials. We're going to name them by their number of terms, and we're also going to name them by their degree. Okay? So for special names, technically this is not a polynomial because the definition for a polynomial was more than one term. So if there is just one term, technically it's not a polynomial. It is what we call a monomial. Right? So we have dealt a lot with monomials whenever we were doing exponent rules because all those exponent rule stuff were really only one term because they didn't have any plus or minus signs inside of them, right? So like something like 3xy to the 4th power would be an example of a monomial. If you have 2 terms, you're going to call it a binomial, and 3 terms, you call it a trinomial. So those prefixes are surely things that you're familiar with, bi being 2, tri being 3, mono being 1. If you have more than 4 terms, 4 or more terms, you would just call it a polynomial with 4 terms or 5 terms or 6 terms, however many terms you have. There's no special names once you get past 3. You can also name a polynomial based on its degree. Its degree is its highest exponent. So if you have a degree of 0, that would look like this, just a 7. You have no variable at all, so there's not an x there at all. We call that constant. The reason we call that constant is because if you graph that, if you graph y equals 7, it's just a horizontal line. It's constant, it doesn't change. If you have a degree of 1, something like 2x, we call that linear, because if you graph something like y equals 2x, you will get a line. A degree of 2 is called quadratic. This is the one place, I don't know who named a quadratic and why they didn't call it a bidratic or something like that, because quad clearly seems like 4, but it is a degree of 2. A degree of 3, so something where it's highest, whenever you're looking for degrees also, you're looking at the highest exponent. So like right here, this exponent right here, the highest exponent I have is 3. It doesn't matter which one comes first or what order they're in. It's just whichever, exponent is highest. So if it has an x to the 3rd as its highest exponent, it would be cubic. Degree of 4 is quartic. And anything 5 or above, you would just say degree 5, 6, 7, 8. There's no special name for those. Okay, questions? So you're going to name these for me. I'll do the first one. So this first one, if I'm looking at terms, I've got 1, 2, 3 terms. So it is a polynomial, but we can be even more specific. Trinomial. And my highest exponent here is 2, which makes it quadratic. So I would call this a quadratic trinomial. typically we're going to put the degree first and then the special name for whether it's a monomial, trinomial, binomial. There. So, excuse me. Try these. Name these for me. What'd you get for number 2? Good. Cubic monomial. Okay. Highest exponent is 3. That tells us cubic. It only has one term, so it's a monomial. Okay. Anna Grace, what about number 3? Okay. Binomial is good. It is not quadratic. What is your highest exponent there? 4. So even if it's not first, it would be 4. And it's confusing because quad sounds like it should be 4, but it is not. Quad is 2. I don't know who named it. It wasn't me. So it's quartic. Q-U-A-R-T-I-C. Quartic, like a quart. There are 4 quarts in a gallon. So, or a quarter. There are 4 quarters in a dollar. So, okay. So that's right. What have you got for the next one? Constant monomial. Yeah, it's not a like mono, like we said, monomial. Okay. Lanaya, what about number 5? Perfect. Cubic trinomial. And Blakeland, what about number 6? Okay, for that, for the degree, we're looking at the highest exponent. For number 6 there, what's the highest exponent that you see? 3. So 3 is going to be cubic. And then we think about how many terms it has. So how many terms does that one have? It's going to have 2 terms are separated by a plus or minus sign. So like 9x to the third would be a term and 9 would be a term. So we've got 2 terms, and on that list for the number of terms, that is a binomial. So knowing this vocabulary is helpful so that whenever you hear a teacher call something a cubic trinomial, you're not totally just thinking, what did she just say? That sounds like some sort of foreign language. And also, it's a good idea to try to use this language yourself to, like, practice it. Plus, it makes you sound really fancy, like you know what you're talking about. So, if you're interested in that as well. All right, so we are going to talk today about adding and subtracting polynomials. Okay? You can only add or subtract like terms. We already kind of know this because when we were solving equations, if we had like a 2x and a 7, we could not add those together, right? Because this 2x had an x and the 7 did not, and we could not put those together. So we're already a little bit familiar with like terms, but what's going to be different with what we're doing today is we're also going to have some other terms that might have exponents, and you haven't seen those in equations yet. So to have like terms, you have to have the same variable and exponents on those variables. So for example, when I have to add together 2x squared plus 7x minus 3 plus 9x squared plus x plus minus 4, I cannot add a 2x squared and a 7x together. They are not like terms because not just the variable has to be the same, but also the exponent. So I was noticing whenever you guys were doing those problems for me after the test, a lot of you were getting answers that were just one number, like 8x to the 6th. So I think you guys were probably combining those, which is fine because I had not taught you how to do it yet. So, you know, I just kind of wanted to see where you guys were at. But we would take 2x squared and we would add it to the 9x squared. So we got to add those like terms. And 2 and 9 will give us 11. And then we'll have x squared. We do not change our exponents here because we're not multiplying those exponents together. To change those exponents, you would have to be doing like 2x squared times 9x squared. We're not doing that here. Our next like terms would be the 7x and the x right here. That'll be a plus 8x, perfect. And then last one, -3, -4, we'll have a -7. That's for if you're multiplying them together. We're doing like -3 plus -4, which will give us -7. Yeah. Okay. Make sure you always look at the sign in front of the number whenever you are putting these together. So like that 3 right there, it is a -3 because the minus in front of it. The 4 is a -4 right there. Okay? All right, let's do the next one together, and then we'll let you try the next two. So I've got a 2x squared and a -x squared. Those are my like terms there, which does give me a 1x squared. Or do I have to write the 1? I do not, so I could leave it off if I want. Then I'm going to look at all my x terms. So I've got -x. I've got a positive 3x. That's it. What's that going to give me?
2x.
Plus 2x. And then for my last terms, I've got 9, -4, and 8. So let's see. That'll be 5 and 8 will give me 13. So plus 13. And this will not be calculator active, so we will not be using our calculator for these. All of Unit 7, for the most part, I think everything in Unit 7 is going to be calculator inactive. So we basically use our calculator the whole time. In 6, we will not use it at all in 7. All right, try those next two for me. All right, check with your neighbor and see if you're getting the same thing. All right. Here's what I have for the answers. Check and see if you guys have the same thing. This may also help settle any disputes if there were any. Three different what? No, that was not mine the other day. It was the kids that was left here. I just have one, but Hunter's got a few, so sometimes they might be around. This was my junk store find right here. I think I told you guys about that. It's pretty exciting. Hunter, he asked for things like that for birthdays and stuff because I won't buy them otherwise. Okay. It was Saturday. Just Hunter, my oldest one's birthday. So he didn't get to have. He was supposed to have his friends over, but he didn't get to because he had been sick all week. So, but he did get an Xbox, which was not my idea. But I was just going to take him shopping and let him pick out what he wanted, which would have probably been like some shoes or clothes or something. It's probably what he would have picked. Yeah. Well, shoes he gets on my nerves because he doesn't need shoes. He has shoes that fit, but he's always wanting new shoes. So, yeah, he's kind of beyond toys now. All he wants is... But my husband suggested, actually, like, we didn't get him the Xbox for his birthday. I was going to take him shopping, and that morning is like, why don't you, my husband's just like, why don't you just get an Xbox? And so, Sam's, it's not the super expensive one. It's not the, well, it's new, but it's like, there's like a S and an X, I think.
Does it look like a glass?
Yeah, we got the S, which is like digital only, and it's not as fast as the X. The X costs like twice as much as the S. So, but it is new. Yeah. So does my husband. I'm starting to see why he suggested he got an Xbox. You need to be saving up that money for something good, like a car.
I mean, yeah, because my parents got me a shotgun for Christmas, but they said, all right, now you're going to pay it back. I wanted to
Yeah.
What? It's $1,200 a year.
Yeah. Not good. Even though Henry is pretty happy just to sit there and watch, really. Henry, is probably just only going
This is really what I want to tell my parents. Is there something that you can get me that I don't want to get? Because otherwise, I'm not going to consider it your opinion.
Yeah. 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 Henry did play a little bit of Tetris on it the other day. He was, because it takes forever for Junk to download on it, so the only thing we could get to download, quick enough to play that night when we got it was Tetris, so we played some Tetris. I like Tetris, actually. It's my kind of gaming. All right. Okay, let's look at subtracting. Okay, subtracting is just slightly different, okay? So with adding, all I had to do was just combine my like terms. Subtracting is going to be slightly different. So, because we have the minus here, it means everything in that second parentheses is being subtracted. So, what we can think of this is there is an invisible 1 right there. And we're going to take that negative 1 and we are going to distribute it to all of those terms in the second set of parentheses. So the first set of parentheses is going to stay the same, but then we're going to have minus 2x plus 7. So that negative just has to get distributed. Really, the only thing most students are going to mess up with this is they're going to forget to distribute, and that last term is going to be wrong. They're not going to have that 7 right, but the other parts will be correct. So then you're combining your like terms, so you don't have any other x squareds. So you'll have 4x squared. You'll have minus 9x plus 11. Are we okay there? You guys, I think I've been looking forward to teaching you guys this section, and I hope I'm right, because this is the first year I have taught Math 1 where I feel like everybody in the class knows their multiplication tables and knows how to add and subtract integers fairly well. So you know that negative 7 plus negative 2 is going to give you negative 9. Integers are just like positive and negative whole numbers. Yeah. So what I see a lot of times is my students are so weak, either they don't know their multiplication tables or they don't know that something like negative 7 plus negative 2 equals negative 9. Like they can't do that in their head. And then so they miss all these problems because they can't do it.
So like if that was like negative 7 minus negative 2,
Uh-huh.
you have to plus it.
Right, so negative 7 minus negative 2 would be a negative 5, yeah, because that would be a plus. So, how would I help you? Because the concepts we're going to learn, especially like today, are really pretty simple. We're just putting the like terms together. As long as you know how to add and subtract, you're going to know how to do it pretty well. But what I have found in the past is my students can't add and subtract. So you can see if you can't add and subtract, you can't do this either. So I'm really been looking forward to teaching you guys this section. I think you guys are going to do well with it compared to normal because I think you are strong in your mental math and multiplication, which is going to be really important for this. Yes?
Yeah, I remember this stuff was easy to learn because like last year I was doing triple and I got a bunch of functions. Hey.
Yeah. It really is something we could have taught you earlier. We could have done this at the beginning of the semester or last year. Like you could have learned this. It's just it fits better in this section because we're going to go further with it to like actual application. Whereas last year you would have just only done just adding and subtracting. So if we do the next one, we're going to distribute that negative, which really just changes the sign of everything. So we got negative 2x squared minus 3x plus 4. And we are going to combine our like terms. So we got a x squared and a negative 2x squared. Negative x squared, wonderful. I've got a negative 4x and a negative 3x, negative 7x, and then a positive 4 and a positive 5, positive 4 gives me a plus 9. Also, it is most standard to write your answer with your highest exponent first and then your next, and then to decrease those exponents. It would be correct, like if you wanted to write it like this, 9 minus x squared minus 7x. That would also be correct. It's just you're usually not going to see your answer choices written that way if you're doing standardized tests. So it's more typical for us to put the highest exponent first. There. All right, try those last two real quick. Son, check with your neighbor, see if you guys are getting the same thing. All right, here are the answers. Check and see. Those look good to you. Well, let me circle them. So, especially this one. There's the answer for this one. There's the answer here. Okay. Questions. All right. We need to do a couple questions from the back of this worksheet because it's got a couple other types of questions. Let's see. So we'll do a couple of these together and then I'll set you loose for these. It was similar. I think they're a little further ahead, but it was similar. Okay. All right. Let's look at. We're going to look at the back side of the worksheet, which the problems aren't numbered, which is annoying, but they like to put these on the EOC.
Well, I remember this from last year. Yes.
Basically, yeah. Because it is,
So much stuff on that year. I was like, I remember looking at a question that day, and I was just like, what's the answer? It's like, I don't even know my name on. Listen, desperate times call for desperate measures.
okay. All right, so, for this one, it's asking for the perimeter. How do we find perimeter? Add all the sides together. All right, so, that means to do this, we would do 4x minus 8 plus 3 minus 2x plus 11 plus y. So we just have to add like terms together. So we got 4x and negative 2x is going to give us a 2x. We got that y right there that doesn't have another like term that goes with it. So we'll just put a plus y. And then we've got negative 8. Oh, let me switch colors. Negative 8, a positive 3, and a positive 11. Yes. So we give a 6. It's positive, so we'll put a plus 6 right here. And that's going to be your answer because it's not looking for a number like the perimeter of this is 10. It's just wanting an expression that is the perimeter. Now, we'll take this further eventually where it might be like giving you this picture and telling you that the perimeter is 15, find x. You couldn't do that on this one because it has an x and a y. But you may see something like that. So for those, you're looking for perimeter. You're just adding all the sides together. So you'll combine like terms. I'm not going to do that one with us together. But I am going to go down here and look at, let's look at that trapezoid that's down there at the bottom. Okay, so we've got 4a squared minus 4ab. We got 9ab plus 8a squared. We got question marks on this side. And we got 7b squared minus 2ab. And they tell us below that the perimeter okay, so our perimeter is going to equal whatever we get when we add all those together, right? So we would take all of these and we're going to add them together. So we get 4a squared minus 4ab plus 9ab plus 8a squared plus 7b squared minus 2ab plus question mark because we don't know what that is, right? So I can't do anything with question mark because I don't know what question mark is, but I could combine my like terms for the other pieces, right? So I am going to put the b first. The only reason I'm putting the b squared first is because I'm looking at the perimeter here and I see that the b squared is first there. So I've got 7b squared. Then let's put together those like terms for all the ABs. So I've got 9, negative 4, negative 2 is going to give me 3. And then I got to put together those a squareds. So a squared, that's going to give me 12. A squared. Oh, this one's hard. Oh, I didn't write this square right here. It's not hard. It's not that bad. I wrote it, yeah, I wrote it right here. Okay, so.
Pardon the interruption, staff. There will be a required meeting in the Media Center right after school at 3:20. It will be quick, but again, we need all middle school and high school staff to meet in the Media Center at the high school at 3:26. Thank you.
What is this? Ooh, y'all in trouble.
I don't know.
Somebody did something really stupid and now the teachers have to hear what they did.
Wow.
What? No, I just go for it and like most of the
Hmm? So, say that again, Riley.
What question marks be 4a squared minus 4ab? It should be the same.
I think you're close. So, let's look at what we're supposed to get. We're supposed to get 9b squared minus 12ab plus 12a squared. What part of that is the same as what we've got? The 12a squared, right? So the 12a squared here and the 12a squared here is correct, which means we don't need to add any a squareds to this, right? The b squared, I'm going from 7b squared, I should get 9b squared. I should add 2b squared to it.
And
All
then
right.
you should subtract 5. Yeah.
5ab. So if that last side is 2b squared minus 5ab, then when I add it all together, I would get 9b squared minus 2ab plus 12a squared. So 2b squared minus 5ab should be our answer. So those are a little bit tricky. Also, let me warn you about something. Look at those rectangles that you see on your paper. They only have 2 sides labeled. Why?
Because the sides of your
The opposite sides would be congruent, right? So if the right side is 5x squared minus 2, the left side is also 5x squared minus 2. So be careful with that because since it's not labeled, a lot of times students forget to add those sides in. But you need to add all 4 of those together. Okay? All right, so this worksheet is your assignment. I know it looks a little bit long, but it should be pretty fast. You should be able to move through it pretty quickly. So yeah, front and back for that. You may want to start on the back because it's probably a little trickier, and you can That way you can ask some questions.